What if the next AI revolution doesn't happen in a massive data center, but inside a robot, drone, or machine right in front of you? That's the promise of NVIDIA's Jetson Orin Nano 2, bringing powerful generative AI and physical AI directly to the edge. In this video, we'll break down what makes this compact AI platform so powerful, from its CPU and Tensor Core architecture to performance, power efficiency, and real-world AI capabilities. We'll also explore how it could power autonomous robots, intelligent drones, smart machines, and advanced AI models without constantly relying on the cloud. So, is this the hardware that could bring state-of-the-art AI into the physical world? Let's find out.
Welcome to this explainer. We are jumping straight into a piece of hardware today that is literally shifting the AI landscape beneath our feet, the NVIDIA Jetson Orin Nano 2. We've been anticipating this moment for years. This board is finally the catalyst that's yanking artificial intelligence out of those massive remote server farms and putting it directly into the physical world around us.
I mean, think about it. What actually happens when you rip generative AI out of the cloud and stuff it directly into a delivery drone hovering over your neighborhood? It's a total paradigm shift. We aren't just typing to chatbots on a computer screen anymore. We're talking about intelligent machines that actually observe, process, and react to our physical environment in real time.
Okay, let's dive into this and get our terms straight. To really grasp this shift, we have to understand physical AI. Basically, this is artificial intelligence integrated directly into machines. Think robots, manufacturing systems, and drones. The real magic here is that all the decision-making happens locally at the edge. The processing is done entirely on the device itself, so there's zero reliance on cloud data centers.
So why is this revolution happening right now? Well, consider where we were just a year ago. To get top-tier AI accuracy, you had to use massive, incredibly power-hungry frontier models running on giant, expensive server farms. But today, the landscape has completely flipped. Highly compact small and medium AI models have caught up. They're hitting the exact same level of accuracy that only the behemoth models achieved last year. And because these models are now small enough, but still incredibly smart, running them locally on edge computing hardware isn't just a pipe dream anymore. It's completely viable.
Section 1. Inside Jetson Orin Nano 2, the engine of physical AI.
78 trillion. That is 78 trillion operations per second, or TOPS, happening entirely on this tiny board. It is just a staggering amount of AI compute, giving these machines the power to instantly decode incredibly complex environments and make high-stakes decisions on the fly.
Now, what's really interesting about this slide is the number 15. All 78 trillion of those operations we just talked about, they run on an energy draw of just 15 watts. That's literally less power than a standard LED light bulb in your house. It's this wild combination of massive compute power paired with tiny energy consumption that makes this absolutely perfect for untethered, battery-operated robots and drones.
Under the hood, here's exactly how NVIDIA is pulling this off. You've got 8 gigabytes of memory, an 8-core ARM CPU, and massively upgraded Tensor Cores. They've somehow managed to pack high-end AI and video processing performance into a form factor that is incredibly compact and surprisingly low cost.
And when you look at the leap in performance, it's pretty undeniable. Thanks to those upgraded Tensor Cores and a big boost in memory bandwidth, the Jetson Orin Nano 2 delivers exactly twice the AI inference performance of its predecessor, the Orin Nano Super. Simply put, it thinks and reasons about its environment twice as fast.
But wait, it's also vastly more efficient. If you run this new board to match the exact same performance level as the previous generation, it uses 40% less power. If you're an engineer trying to get a drone off the ground, a 40% power reduction is an absolute game changer for thermal management and battery life.
Of course, incredible hardware doesn't mean much without incredible software, right? NVIDIA's open software stack actually allows developers to run state-of-the-art large language models and vision language models natively on this edge hardware. It supports powerful, highly optimized models like NVIDIA Cosmos and Nematron, right alongside popular open models like Gemma 4 and Qwen 3. The machine doesn't just see pixels anymore. It actually grasps the context of what it's looking at.
Section 2. Robots in the real world. So let's talk about who is actually using this. A prime example is Wing, Alphabet's drone delivery subsidiary. They are currently evaluating this board for their fleet to push real-time AI perception to the absolute limit. Picture a drone approaching a residential yard.
instantly recognizing dynamic, unpredictable obstacles, like a running dog or a misplaced lawn chair, and figuring out how to land safely, all without ever pinging a cloud server for instructions.
Danuka Abiwardena, the head of perception over at Wing, puts it perfectly. Drone delivery depends on AI that can enable fast, reliable understanding of the real world. Because these drones make processing decisions right there on the actual device, rather than waiting on an internet connection, they are vastly more responsive and way more energy efficient. Every single millisecond counts when you're navigating physical space.
Let's move to and see how this builds straight into our own living rooms. The consumer robotics company Matic is adopting this board for its home cleaning robots. And the upgrades are wild. We're talking conversational AI so you can literally just talk to your vacuum, gesture detection to command it with a wave of your hand, plus precision mapping and full autonomous cleaning behavior. They are effectively giving a standard household appliance a high-level real-time brain.
Navneet Dalal, CEO of Matic Robots, states, "With Jetson Orin Nano 2, Matic can run state-of-the-art AI models at the edge in a compact home robotics platform built for real-time perception, interaction, and navigation. For us, this means your home robot can finally understand complex, constantly changing layouts, like a chair that got moved or a toy left on the rug, and seamlessly clean around them instantly without any lag."
Section 3. The Edge Computing Future.
3 million. There are already over 3 million developers actively building on NVIDIA's robotics stack today. That is an absolute army of engineers, innovators, and problem solvers designing the physical AI of tomorrow. It really goes to show just how widely adopted and trusted this entire ecosystem has become.
And they have incredible industry backing. Just look at this massive network of hardware ecosystem partners. AAON, AidLink, AdvantageTech, Atina, Antmicro, Aptiv, Avidia, AverMedia, the list goes on. They are building customized carrier boards and reference designs that drastically accelerate the time to market for pretty much anyone looking to deploy physical AI globally.
So the crucial point is captured beautifully here by Deepu Talla, VP of Robotics and Edge AI at NVIDIA. He says, "Frontier intelligence has reached the edge. Frontier models that used to run inside data centers last year can now run in real time on entry-level Jetson systems. It's just a wild acceleration in how fast top-tier AI is shrinking in cost and size while absolutely exploding in capability."
Which leaves us with this final, really exciting question to consider. As frontier AI rapidly moves out of the data center and directly into the delivery drones dropping packages at your door, or the robots cleaning your floors, how will edge computing change your own daily interactions with technology? It's a fascinating and fast-approaching future. Thank you so much for joining me for this explainer, and I highly encourage you to go explore more about the incredible world of physical AI.